Hello, welcome. This is Sokobond Express. This is another one of those games where being out of this main screen somehow stops the music from playing. But it's okay. It's a pretty nice ambient sound. So I'm gonna keep it on. I'm not gonna play any background music. Anyway, if you remember, I have played Sokobond before. So it's like a 10 episode series, I think. Uh, it's not really a playthrough, more than a relook. I had like a 3 episode series way before that, and then I decided to finish the game for real. I didn't actually finish Sokobond because there were sigils to collect, but I felt like I had spent enough time in that game to consider it a successful playthrough. And not so recently, they released a combination of Sokobond and another game that was another puzzle game. I'm not sure if it's by the same creator. I don't think so, because the styles are just way too different. But it might be for like copyright reasons. You can't really make a game unless those two creators collaborated, or unless those two were the same creator. Anyway, basically this is a combination of the game Sokobond and the game called Cosmic Express, I think. Gosh, I forget. I have that game, I think. Do I? Yeah, it's called Cosmic Express. Let's see. I think it is actually by the same creator. Who created Cosmic Express? It doesn't say here. I have to go like the store page. Gosh dang it. Okay. It's by someone known as, yeah, Dragnic and Friends. Who, well, they were the publishers of this game. And I'm assuming they're also the publishers of Sokobond Express. Yeah. Anyway, so the concept of the puzzle sort of is just a combination of both Sokobond and Monsters Express. And if you haven't seen Monsters Express yet, it's basically a game where you sort of draw tracks. Oh, what is this background? So yeah, you can see here, you can draw train tracks basically. And now the train track starting from this starting atom over here, it goes down, forms a bond, and creates a molecule, which is how Sokobond works. Yeah, at the end of every Sokobond level, you also get like a cool trivia fact. Smartphones are stuffed with elements. One device has estimated to use around 75 elements, which is roughly 2/3 of the whole periodic table. A periodic table having about 118, exactly 118 elements at its current state. Question mark. Okay, so alright, typical exit menu. There's sorry. There's also a light mode. I'm gonna show it for a bit. Yeah, hope you didn't get a flashbang there. That was light mode. Both are playable by me, but I think the dark mode is not too dark. And so, alright. Now we have an oxygen atom. So with two hydrogens and one oxygen, the most logical molecule to form here is just H2O, which is water. And I like that it shows you the preview. It doesn't show you anywhere else though. I think in like the demo version, it used to be like a symbol over here to show you what the current molecule being made was. Now it's replaced with a hint button. Okay. Alright, so that's how you make H2O. Some chemical elements are considered endangered. The indium that we use to make smartphone touchscreens work is one of them. Endangered meaning low in supply, I believe. Another one is helium. Helium is being low in supply, seeing as how it consistently escapes the Earth's atmosphere due to its very low density. Alright, let's see what the hint does. I want to see just in case. So I'm going to reset here. Hint. Okay, so this describes the final molecule that we are supposed to make. Okay, cool. Alright, let's continue. Level 3. Can I just walk here? No, the path cannot cross over existing molecules. Although after the bond here, moving forward would technically be possible because the entire set of 4 atoms would be moved along with it. It's not possible here. You just can't go backwards on this pre-existing track. Okay. So I simply need to make 3 combinations and that should solve it. So it looks like the preview can cross existing... I wonder if this actually does... Okay. Atoms don't hit tracks. Good to know. Helium was one of the first things to exist in the universe. Humans use it in hospital scanners, deep sea diving, party balloons, and to give themselves a squeaky voice. The first actual element in the universe is hydrogen. And then helium was formed during the collision of hydrogen due to the high temperature, causing nuclear fusion, I believe that's what it's called. Nuclear fusion, yes. I don't remember why helium gives people squeaky voices, but I think it's because it is low density, as per usual. Which is why if you suck in a very high density voice, like hexafluoride, I think, is that what it's called? There's also one gas that makes your voice very, very deep. Alright, there's the beta section, which is the second world, I believe. Each world has a pretty small number of levels, but I guess that's not a problem. Let's go to level 4 of alpha. Alright, we have a carbon atom here, which bonds to 4 to make methane. So, like Sokobond, it is good to note how a molecule or how an atom can bond with molecules here. With four hydrogen atoms, this atom itself, this carbon atom, has to bond in 4 different ways. So it essentially needs a connection in all 4 of its orthogonal directions. We currently have one that is forced to be below, so we need one to the left, one to the right, and one above. I'm going to believe that this is the one that goes above, just because a very ideal movement is this way. And then this can't really be collected from below. You know, can't really stick to this because of this being in the way. I also can't move here, and you can see an X there to represent it. That's because if I did do that, this hydrogen molecule would collide with that one. Yep, that's a collision. Which is an opus magnum thing. Anyway, so this should solve the puzzle. No, it doesn't because of the collision. So I guess I have to dodge out of the way. Alright, cool, that works. Helium is rare on Earth but abundant elsewhere in the universe. Some people believe that mining on the moon could be a viable alternate source. Possibly, I don't know much about this. There's a lot of things we can mine across the solar system for now. Besides the moon, the Mercury is also a viable option, or it's something that scientists would like to see, because mining on the Mercury means that you can build stuff on Mercury, and building stuff on Mercury means you can get closer to the sun, and being closer to the sun means a much more efficient means that solar panels basically become a much more efficient source of energy. Alright, CHO and H. A molecule you could make with these 4. I don't think double bonds work. Does this form a double bond? Oh my gosh, it does form a double bond. So it naturally forms a double bond already. Okay, this could be CH2O, which is an aldehyde, I believe. So basically C connects with O in the double bond and it connects with both hydrogens to form all 4 bonds here. So something like down at the bottom, down at the side, and then down at the top should be good. Then we can wrap around like that. Looks like you can't change the direction of the entrance, so you can't walk in through here. You have to go around. Good to know. Yes, so this is formaldehyde. It doesn't have a name, which is interesting because I'm pretty sure you would have called this something. Most chemical elements are formed by stars. These elements spread around when the stars explode and can become new things. You're actually made from stardust. Yeah, when the first things in the universe, first celestial entities formed, they were all just stars made from the massive density of hydrogen clouds just being pressured into forming stars. And then from there you could high temperatures and high gravity allowed nuclear fission to happen, which formed a bunch of other elements along with it. And then when the stars exploded, it kind of spewed all those stuff outwards. Yeah, so carbon is actually a result of that, which is why we're made from stardust. I also want to see what the intended was. Yeah, it is formaldehyde. It just didn't say the name. I'm pretty sure they say the name of everything else, right? Or am I tripping? Like, if I went back to methane, this is methane. Let's see if they call it methane. I guess it's not called methane. They didn't really not call these things by their names. I guess not. It just shows you the element that you made, the molecule that you made. Interesting. Alright, let's do beta. Hi, this is a green line, but should be identical. Yeah. Also, yeah, it is possible to hang atoms off tracks. I believe we've already done this. Alright, so I can do this. Can go around to form a bond of hydrogen and then come back. And that should be it. So now we're starting with hydrogen, which is not the central atom. I guess that might be the mechanic of this world, where we control not the central atom. Anyway, natural rubber doesn't come from rubber trees. Soviet scientists discovered it extracted from a species of dandelion and used it to make tires during World War II. Oh, it doesn't just come from rubber trees. Interesting. I guess it's not really called rubber anymore then. It's like the sap. But how many dandelions would you need to make tires though? Given how small dandelions are. I guess you need a lot of them. Alright, what is this? 2 H's and 2 O's is probably hydrogen peroxide, which is H with 2 O's sandwiched between each other. So by doing this, I can probably just form... yeah, I can form a hydrogen peroxide molecule. And hydrogen peroxide is actually really detrimental to your skin. Not as much as bleach. Is bleach hydrogen peroxide? I don't think it is. But it damages your skin really hard, which is kind of surprising, being just one atom away from regular water, that it has such properties. I think it's due to its like low stability, which is why it does that to your body. Not sure. Anyway, bacteria can do more than just make us sick. Metal absorbing species can help clean up metal pollution or recover valuable metals from electronic waste. It's like worms that eat styrofoam, which is good because styrofoam doesn't biodegrade very well. Level 3. Okay, we're getting more complicated here with our molecules. Can I just guess? Okay, I can't just guess a solution. But what molecule do you think I should make here? I'm thinking this forms a double bond with something. Yeah, like a double bond with oxygen, and then it forms another single bond with oxygen, and then oxygen forms a single bond with hydrogen. So it's ONOH. Yeah. Which means the O's do not connect. So I probably have to connect to the H first, which means that this forms a singular bond with nitrogen, and that will form a double bond with oxygen. But I have to do it in a special way because doing this gets us stuck. So maybe the nitrogen has to be here. Yeah, okay. Sure. By coating a boat's hull in copper, you not only protect the wood from destructive shipworms, but the boat will go faster because of fear of weeds and others hangers on, like barnacles. Cool, it's like slippery and stuff. Actually not slippery, it's just really hard to cling on to. Anyway, gamma. Let's level 4 and 5 first. Oh my goodness, big map. Okay, this looks like I don't know what it's called. It's N2H4. It's just N bonded with 2 H's each, and then the N's bond to each other. Doing this doesn't feel very good though, although it's possible. I will have to form a direct bond of nitrogen, which doesn't seem that easy. So maybe just this first, and then this. And I can form other bonds later on. Like I can form... or I can do this. I want this one to bond to this nitrogen. Oh wait, no, the problem is that it forms a double bond automatically. I just realized that. Which means that this molecule, this atom over here has to form 2 hydrogen bonds first. So maybe this has to happen. But the problem is that this can't happen because I'm stuck. So this maybe? Yeah, that's a better way to do it. And then like this, and then this. Yeah, that should be fine. And it works, it doesn't collide because this is not there anymore. So that's good. And we should be good to go. Cool. How did dinosaurs die? Well, sediment from 66 million years ago contains lots of iridium, which is rare on Earth but common on asteroids. And yeah, that's how we figured it out. Space rock. And then some French word, I can't read that. Anywho, let's continue. Level 5. Alright, this looks intimidating. But it's the O and OH thing again. It's the same. So H bonds with O. Maybe like this. Well, I'm wondering how this can let us bond to the nitrogen though. Because how do you form a nitrogen bond here? Maybe not. But this can't happen either because we already tried that. Right? Okay. The O also bonds with N directly, so if I just bond with O directly, don't I then have to bond with N immediately after? How would that work? Maybe I have to do this. Yeah, this gets the O to be on top, which allows the bond to happen like so. Does it matter which? I think it does, in fact. This actually doesn't work, because now this nitrogen can't ever bond with this oxygen anymore. But if it were the other way around, it should be fine. I can actually just do this, yeah. That is the most efficient route. Cool. There you go. Mars gets this reddish-brown color from the iron oxide molecules on its surface. You have to go to space to see iron oxide though, it's more commonly known as rust. Yeah, it's iron oxide. It's actually iron 3 oxide. Is it iron 3 or is it iron 2? It's iron 3. Yeah, iron 3 meaning that the iron has 3 charges, 3 units of charge on it. Iron 2 is green. And iron 2 exists as FeO, I think. But iron 3 oxide or rust is Fe2O3. Yeah, I'm just rattling off numbers here. But basically meaning that every unit of iron oxide contains 2 ions and 3 oxygens. And that's the only way you can balance the charges out to make a 0 charge molecule. Alright, that's 2 walls done. Next is gamma. Hello, what is that? That is a free electron. Okay. This is H+. So this hydrogen is protonated, which is easy way of saying it is positively charged. Yeah, electrons are negatively charged, which means that this probably forms. Oh, this is like a straight tile you can't hit. This basically balances it out. So a hydrogen plus a negative electron forms a regular hydrogen atom, which can then bond here. Does a bond form otherwise? Whoa. A bond would not form otherwise. Okay. Good to know. But I'm stuck, so I have to go the other way around maybe? Yep. Okay. An ion is just an electrically charged atom, right? Atoms become charged when they lose or gain electrons. Positive ions have lost some electrons and negative ions have gained some. Alright. Actually a hydrogen positive ion is really just a regular proton. It is just a pure proton. Okay, so H2O now. It seems to be fine so far. I think all I need to do is collect this. I don't want to bond with that. I want to bond with you first and then I guess walk around. Yeah, we should be fine like that. So that uses the fact that you don't naturally bond with regular hydrogens. You must be a normal hydrogen atom first. Electrons orbit the nucleus of an atom in layers. Atoms are most stable when their outermost orbit is full, which is why so many atoms are keen to lose, gain, or share electrons. Yeah, and this losing, gain, or sharing electrons is how molecules are made. Each bond you see that's grey is actually a pool of shared electrons. So each O and H right now, they're sharing 1 electron each, which allows both oxygen and hydrogen to obtain a full set of electrons in their outermost shell, which is known as a valence shell. And that keeps this molecule very stable. This is not always the case for certain elements, like for atomic numbers of like higher up, you can actually gain more than the quote-unquote stable amount of electrons in your outer shell. Alright, so we have a doubly positively charged oxygen, so we need to collect both of those. I'm assuming this doesn't work though, yeah. So doing this just forms your regular OH already. Does this work? Yes, it does. Alright. Cool. So it looks like, okay, I want to actually note that you don't need to be a regular atom to bond an H. You just need an atom, an electron. So one electron can bond with one H. And this works because, again, O and H form a bond by sharing electrons. And the way to do that is they provide one electron each to form a pool, or the bond. So all you need is one electron to form a bond with H, but if you don't have that, you can't form a bond. Now at this point, you would have one electron, so you would form a bond with one H, and you need the second electron to do another bond. Doesn't that technically then mean that I can just do this? No, because it's a collision, right? So this has to happen. Alright, fair enough. Cool. Positively charged ions are called cations and negatively charged are anions. Remember that onions which sound like anions? That's not true. Make people cry and that's negative. Or I could just think of cations as being positive because cats are cool. And they have paws, therefore positive. Delta. Ooh, 2 extra sections coming out of that. Alright, let's keep going. Doubly positively charged oxygen. So I need to gain both of those. Okay, so this technically means that I can form a single bond with nitrogen first, right? If I didn't, I would form a double bond, which is okay, but not necessarily the best idea. Although I could always just do this, right? Yeah, that just solves it, I think. Okay, odd. Yeah, that just solves it. Is this what you wanted? I guess it is, wow. Sure. This doesn't feel like the most obvious, like, problem with that. Because we haven't had a level where you are forced to not make a double bond first. But I guess that's fine. Enzymes in saliva break down food to release flavor molecules which are then detected by your taste buds. A dry mouth will make food far less tasty. Good to know. Level 5. Okay, lots of oxygen here. This might be the first ring we make. And this is also a reason why. Okay, so this is the first level that introduces to us not making full bonds at once. If I just collected both of you and made a bond, it would form pure oxygen. And I can't do anything to these guys anymore. Yeah. What happens if I fail? Like, what happens if I do this? Okay, nothing happens. Let's restart. So we need to actually form a singular charge first, and then form a singular bond. Afterwards, collecting this would form a second charge, therefore forming a second bond? No, that's not true. That's odd. But I guess I can try something like this. I wonder why... Yeah, I wonder why this one doesn't form. Maybe it just doesn't because it doesn't. It's a lock. What does this lock mean? That I can't change anything about the level? Okay. Cool. So what am I supposed to do? Because I think I know the final state is a ring of 4 oxygens. Oh! Well, a ring of 4 oxygens doesn't require a double bond at all. It's just 4 single bonds, because then each oxygen would have 2 bonds coming out of it. Which is what oxygens require for a full shell. Alright, so this is fine. It just has to be a ring though, which means that something like this has to happen. And I have to go on the other side. Which means this would fail. Okay, so maybe something like this instead. This might be better. Yes, this feels okay. Ooh, there's a problem though, because I can't really do anything after that. Maybe the bottom one first. This feels promising, but not quite. Maybe I have to go down this way. Maybe this is the better choice. Yeah, this feels like a better choice here. I can do this. No. I can do this. No, that forms a break. What does that break? Oh, because it hits this tile, and this tile is a solid tile. Okay. That should work though. But now I'm stuck because I can't access this anymore. That's really odd. Okay. Well, I can always like flip that, right? So like, maybe this first? And then this? What a conundrum. Maybe this is fine. Yeah, this could be fine. Oh, we still get stuck though. That's a really weird problem to have. Okay. If I did this... No. Maybe this is fine. No, it's close, but not quite. Because I need to come down to this spot first. So no, this is not good. If I had it like this way though, I could just walk down like this and then, well, that wouldn't even solve the problem either. But this might if I made it like a reverse L shape, and I could just walk in like this. Okay, so I'll go to make this a reverse L shape. I think that's doable. That's a reverse L shape. It's a reverse L shape, but not in a very good way. Double bond doesn't work either. Oh, this is tough. Interesting that this works though. This doesn't get us through well enough. I can't just do this either. Okay. So what other shape can I form? Like... maybe I form like some L shape like this, a regular L shape. That's a regular L shape. I can go up here. Oh, and that should be it. Nice, alright. Cool. A little bit of guess and check. But that works. There you go. I forgot what this is called. Tetra oxygen, I think? Yeah, that's called tetra oxygen, which is like one of these special molecules you could make in Sokobond. Anyway, slime houses dissolve food, but pineapple bites back. Pineapples bite back. They contain bromelain, which breaks down protective mucus in our mouths. Raw skin and acidic fruit is a pineapple tingle. I didn't know that pineapples were acidic, but sure. So, okay. Nice. Interesting to know. Cooking pineapples will actually remove this bromelain, probably through some chemical reaction. It just is what I'm guessing. Yeah, that makes sense. Alright, well that's your first 3 worlds. I think I could end off the episode here. I don't want this to last for too long. We can continue the next episode next time. Yeah, the next section next time. Alright, well that was pretty cool. Can I go back to the main menu? I can. So that was the first 3 worlds of Sokobond Express. I'm pretty excited to continue playing this soon. Yeah, pretty calming, fun puzzle so far. And also having a lot of little trivia that I can resonate with, which is always nice to have. Alright, until then though, hope you enjoyed this video. I'll see you guys next time. Bye bye!